So in this demo, what I'm going to show you is some copper reacting with silver nitrate. And I have the copper in this test tube over here to the left so that you can observe it while the reaction is happening. I have another piece that I'm going to add into this center test tube, which already has some silver nitrate in it. And then on the right, I have another test tube that has silver nitrate in it, just so that you can observe it, what it looks like without any copper in it, while the center one reacts with the copper. So I'm going to go ahead and add that strip of copper to the center one, and then I'm going to turn on the timer just so that you can kind of see how long this takes, because I'm probably going to speed this video up a little so you can see this reaction happen to completion without having to wait so long. But just to give you an idea of how long this really is taking, I'm giving you that timer down below for reference. So here we go. Starting our timer. If it would start, that'd be great. There we go. So a little bit of a delay, but not too bad. It's just for reference anyway. Okay, so my timer shut itself off after a while. I guess it got bored, but I wanted to give you guys a closer look. I've been shaking this, trying to get this chunks off. Get a little closer look at this. You should definitely be able to see some changes here. And I know that this doesn't look super pretty, but you can kind of see at the right angle some little spiky, silvery looking shards in there, and those are silver. So in this demonstration, we had that piece of copper that we started with, the nice bright shiny strip of copper, and we added that to a solution of silver nitrate. Now, silver is Ag, and nitrate isn't just nitrogen. Nitrate, with that 8 ending, is a sign we need to flip our periodic tables over. Look at that list on the left side on the back, and that'll tell us that nitrate is in fact NO3. It has that little negative sign up top. Don't make that think that it's -3. That's just negative, meaning -1. 1's the only number we could leave off there. The 3 is clearly at the bottom, and negative is at the top. So the charge is always up there at the top. So nitrate is a -1. It's a little bit of a special group on the back, but we treat it the same way as every other ionic compound piece. We find the symbols and the charges. So silver is Ag. It's also a little bit special. It's a transition metal, and most of the time we don't know the charge of transition metals, but silver is one of the special ones that we do. Silver has a +1 charge. It's just like zinc and aluminum. Silver is a +1, zinc is a +2, and aluminum is a +3. Those are the only 3 transition metals that have a charge. Now, lucky for us, this +1 is going to cancel out with nitrate's -1, so we don't have to do anything else other than shove these 2 pieces together to get our formula for silver nitrate. Now, I want to help you kind of get a little bit of an introduction to predicting the products of a chemical reaction, because that's what we're going to be doing pretty soon, and you can probably start to do it already. You just need a little bit of help kind of looking at these chemical reactions the right way to figure it out. So I want to help you do that here. So let's draw our arrow for our chemical reaction. This is where the change happens, and we're going to work together to figure out what we're making here. So let's look at what we are starting with. With this element and compound, hopefully this is starting to seem like a single replacement reaction. Like maybe this single copper here is going to come over to this compound that thinks it's nice and stable and happy together, and then suddenly break up that nice, stable, happy compound so that it can be part of the compound and kick out another part. And that's exactly what's going to be happening here. So noticing what we're starting with and identifying the type of reaction is going to help us figure out what's happening here in that test tube. So copper is going to come over and break up our nice, stable, happy compound, and it's actually going to be replacing the silver here. That's because they're both metals. They both like to be positively charged. So copper can replace silver in this compound and help complement and cancel out nitrate's negative charge, because we know opposites attract. So silver is going to get kicked out of this compound. Now silver is going to be our single element, and it's not a diatomic, so it doesn't even get a little 2 to keep it company. And now copper is going to be getting with that nitrate. Now, there are going to be a couple of rules that we have to tell you about what charges elements like to have when they're forming these compounds. But long story short, copper likes to have a +2 charge. So that's what we're going to give it as it's forming this new compound with nitrate. And nitrate always has the same charge, that same -1, as when it was over there with silver. But in this situation, what that means is that that -1 and this +2 aren't going to cancel out 1 to 1. We're going to have to cross, drop, reduce here, and that's going to get us copper nitrate, copper 2 nitrate to be specific, and that 2 is going to be crossing over onto the nitrate, which means we're going to have to put those parentheses around the outside of it. Let's get this to show up and be nice and neat in our slide here. So those are our products of this chemical reaction. And all we needed to know was the type of reaction and then a little help with some transition metal charges. But that is our reaction, and now all you've got to do is balance it and you're ready for your next demo.